three blocks A, B, and C of masses 4 kilogram, 2 kilogram, and 1 kilogram respectively are in contact on a frictionless surface. If a force of 40 Newton is applied to the 4 kilogram block, then the contact force between A and B is, because this is a really good question. Let us see how to solve this. So first what I'll do is I'll draw the combined diagram here, which means I'll select all the three masses together and name them A plus B plus C, right? The complete mass A plus B plus C, and then analyze what are the various forces acting on it. So the first force acting on it is F external, right? Is F external, and the body will experience a movement in the positive x-axis, right? So if we have to write the Newton's laws of motion here, third law of motion, what do we write here? We can write that F external, right? F external would be equal to mass into net acceleration, right? Or we can write that F is equal to, in easier way, we can write F is equal to ma. And what is F? It is given that 14 Newton. So it is 14 Newton. And mass, what is mass is equal to? So it is 4 plus 2 plus 1, right? So we have 4 kilogram plus 2 kilogram plus 1 kilogram. So mass is actually 7 kilogram into acceleration. And therefore acceleration is 14 by 7, which is 2. So we have acceleration is 2 meter per second square, right? Acceleration is 2 meter per second square. Now let us see the case between A and B. So the contact force between A and B is, okay. So let us draw the diagram for A and B. So this is figure A, right? Now what I'll do is, now I'll draw these bodies separately so as to explain what happens when they come into contact, okay? See, now when you push A will come in contact with B. Most of the students get a confusion here regarding how to draw the normal reaction. We'll come to that. So see, this was the case earlier. Okay, this was the case earlier, and what happens is, when F external is given, right? When F external is given, A comes and collides with B. Okay, A comes and collides with B, and give me a second. Say this is what we get. Okay, so the distance between them is reduced. Now A and B are moving together is what we visualize here. So if we break this visualization into two parts, let us see those two parts simultaneously. So A is colliding on B, which means A will give a force on B, right? Let us call this force as the normal reaction. And this normal reaction, we'll have to write it in detail so to understand to get the concept very clearly. So this is normal reaction on B due to A. Okay. Now by Newton's third law of motion, an equal and opposite force will be given on A, right? So if we mark that force, we can write like this. This is normal reaction acting on A, right? Normal reaction acting on A due to B. Okay. Now, if we take the free body diagram of A alone, let us see the various forces acting on it. Let us see the various forces acting on A. So for the body A, right? For the body A, okay, let us try to even more simplify this. So let us draw the diagrams. Sorry, let us draw the forces acting on A alone. See, the first force acting on A is normal reaction, right, from the surface. Normal reaction on A from the surface, and then we have weight acting downwards. So weight acting downwards, right? A mass of A acting downwards, And then we have the F external here, F external. And now what did we see? We saw that there is another force, normal reaction on contact force, right? Normal reaction on A, which is happening due to B. Okay, so this is the condition for, these are the forces acting for the block A. Now let's see, is there any vertical motion? Is there any vertical motion? No vertical motion, right? So there is no vertical motion. Now, if there is no vertical motion, what does it implies? This implies that sigma Fy is equal to 0. And if sigma Fy is equal to 0, it implies that forces along the positive Y would be equal to forces along the negative Y. Therefore, we can say that normal reaction on A due to surface is equal to MA into G, right? But what will be the condition for horizontal motion? Horizontal motion condition will be sigma Fx is equal to m times A net, right? And what is A net? We derived A net to be A is equal to 12. So here we can write that this is mass, okay, not mx, it should be ma. So this is ma. What is the value of ma? Mass of ma is 4 kilograms. So we have 4 into what is A net? A net is 2. Now what is sigma Fx? See, what is the net direction of motion? Net direction of motion is towards the right, right? Net direction of motion is towards the right. So we'll draw the net direction of motion first. Net direction of motion is towards the right. Again, net direction of motion is towards the right. Where is F external acting? F external is acting towards it. So F external and the direction of motion are in the same direction. But where is normal reaction acting? Normal reaction on A due to B is acting in the opposite direction, which means we'll take F external to be positive and net external to be normal reaction on A to be negative. In which case, what would be sigma Fx? Sigma Fx would be positive F external minus normal reaction on A due to B, which is actually the force acting between A and B. So what is force external? Force external is 14 Newton, right? 14 Newton minus NAB is equal to 4 into 2 is equal to 8. Therefore, 14 minus 8, 6 is equal to normal reaction on A due to B. Well, see, I think I'm taking longer than usual to solve these questions. Usually, you don't get the luxury of time to solve this question in such a detailed way. But again, the reason to explain this much is to make sure that you understand the concept behind every every free body diagram of the given block. So what I would suggest is you can try doing the same question. But this time using the block B. So we have, how do we do that? We draw the combined figure once, right? And then we, instead of taking A, we take B, and then we understand the various forces acting on B. We draw the effect of F external, the effect of normal reaction on B due to A, and then let's find out what are the what would be the value of NAB if you do so. So try doing it, get back to us, and after doing that we'll move on to the next question. Okay, now this time we have a question based on law of conservation of momentum. Let's go to that.